Okay, so welcome back, and now we're going to do an example of applying the formal definition for a limit at infinity. So the first thing we're going to do is they want us to prove this is true using the precise definition, the formal definition. So what we're going to do is we're going to let epsilon be greater than 0, right? So we're going to pick epsilon greater than 0, right? Okay, now what we need to find is we need to figure out what we want to make n, right? How are we going to determine n? Well, let me do some scratch work over here, see what we can come up with. So now, again, we're trying to find what? The distance between f of x and L. So what's L? 2. So let's set this up. So we got 2 plus 1 over x minus 2 is less than epsilon, right? That's what we want. So that means the absolute value of 1 over x is less than epsilon. And since x is going to be a positive number, why? Because it's going to positive infinity. So x is going to be positive, so we can write this as 1 over x is less than epsilon, right? Now, well, the thing is realize that we want this to be true for all x greater than n, right? So what should we make n? Well, let's solve for x here. If we solve for x, we get x is greater than 1 over epsilon. Okay, so let's make 1 over epsilon equal to n then. Okay, makes sense? So, let n equal 1 over epsilon. There we go. Now, so what do we need to do? Well, we need to see what happens here, right? So now we're going to use the definition, right? And it says, so therefore, so here's the symbol for therefore, triangle and dots. So therefore, for all x greater than n, what do we have? We have, and we have what? We have the absolute value of f of x minus L is equal to the absolute value of 2 plus 1 over x minus 2, which is equal to the absolute value of 1 over x, which is equal to, well, do I need to go that far? Yeah. Now, what do we know about this? Well, 1 over x, so again, for all x greater than n, well, n is equal to 1 over epsilon. And this is for all x greater than n. And now we're taking 1 over x. Well, 1 over x, let me do it this way. Let me put it down here. So this is equal to 1 over x. And 1 over x is less than what? N. Why? If x is greater than n, then 1 over x is less than n, which is equal to what? Oh, hold on. No, I'm sorry. This is This should be 1 over n. So if x is greater than n, then 1 over x is less than 1 over n. Okay? Why? Because if 3 is greater than 2, 1/3 is less than half, right? So again, always put numbers in there if you don't remember. So 1 over x is less than 1 over n, but 1 over n is what? Epsilon. So we just showed that for all x greater than n, if we're given this, right? Epsilon greater than 0, n equal to 1 over epsilon, which is obviously greater than 0, right? So it meets the conditions for the theorem, or for the definition. And it says, therefore, for all x greater than n, what do we have? Well, we have that f of x minus L is less than what? Epsilon. And so the conclusion is what? So, therefore, the limit as x approaches infinity of 2 plus 1 over x is 2. And that's it. Have a great day.